Welcome to the GCSE Statistics Higher Session 6. This session is focused on cumulative frequency and box plots and consists of 5 subsections: cumulative frequency curve, interquartile range, drawing box plots, calculating outliers, and comparing distributions. Drawing a cumulative frequency curve. You must ensure that the points plotted are at the end of the class interval, not the middle. The points need to be joined with a smooth curve. The characteristic shape of a cumulative frequency curve is an S shape, which flatlines here at the final coordinate, meaning it goes to a plateau. So we have this shape. We can have something that looks steeper, or something, again here, as you can see, that is a flatter line, but it still has the characteristic of an S-shaped curve. We do not use a ruler when drawing a cumulative frequency curve, and you must use a pencil so that you can make any corrections if necessary. Really important, on this axis here, the y-axis, we are always plotting the cumulative frequency. And on the x-axis, we have on the x-axis here, we have the variable. So at this point here, we are having this side is the cumulative frequency, which is actually the y-axis. And here we have our x-axis, where the variable is plotted, making sure this is at the end of the class interval. So, before we can draw a cumulative frequency curve, we must calculate the cumulative frequency from the frequency. The cumulative frequency is basically a running total. So we can see here our first category goes from 0 to 1, which is the same as up here. So our frequency is simply 23. An easy way might be to calculate this next to the frequency. Once we have our first frequency, we add this to the second frequency to get 58. And we can see here that goes from 0 to 2, which is our second category here, 58. And we follow this pattern. We take our last cumulative frequency, add the next category, 82, our next cumulative frequency. Add 12 to 82, and we have 94, our next cumulative frequency. 94 add 5, 99, and 99 add 1, we have 100. So our two cumulative frequencies are here. Now make sure that this last number corresponds to what's quoted in the question. This question is about 100 days, keeping a record about the times, arrival times of trains that this person, Salim, took to work. So before we can draw the curve, we must have the cumulative frequency calculated. Now we're going to plot this onto a cumulative frequency diagram. Now here, we must be plotting against the upper end, the end of the class interval, against the cumulative frequency. So we're looking against 1 and 23. Be careful on the scale here. We're going up to this point for 23, 1.5. 2 and 58, 3 and 82, 4 and 94, 5 and 99, and lastly 6 and 100. So once your points are plotted, you then need to take a pencil and draw a smooth curve through these points. We need to start at the origin here, and then taking your pencil, smooth curve through the points. And we're going to have the characteristic S-shaped curve, and we can see it plateauing towards the final coordinate here. Extracting information from a cumulative frequency curve. You need to be able to use your curve to estimate a number of different points. The first key point is the median, the middle point. Using this example here, we have a cumulative frequency, a total of 100. This is our final point here. To find the median, we take the total of the cumulative frequency and we divide by 2. So we are looking for the 50th value. That's why here we have the value here marked 50 across, down to the line we have 1.8. This is the median, 1.8 in this case. We can then use our curve further to be able to estimate the quartiles. This is splitting our distribution into quarters. We have here half. This is where we are going to find the median. This is quartile 2. To find quartile 1, the lower quartile, we will be here at 25. Going across, down, and here we will have quartile 1. The value that comes off is quartile 1. To be able to find quartile 3, so we have here quarter 1, 0 to 25. Next 25, we're up to the median value coming across to 1.8. And then here, a further 25, we have 75. This across, down, is going to be where our quartile 3 is. Okay, so making sure when we actually do this, we will be using a ruler. So first step, if we go to 75, halfway here, we'll be going across to our line and then down here to our point. Okay, and then we'll be able to read off our value for quartile 3 and similarly here for quartile 1. Making sure that's at the right point there, slightly further up to make sure it's exactly at 25, the halfway point. And then drawing down here, that needs to go across slightly. Let's have a look at this. So going back to this line here, just extend it slightly. Oh, not that one, this one. Extend it slightly more to the line. And then as you take your other line here, that's exactly on the screen, you'll be looking here at a value of approximately 1.1. And this here will be our quartile 1. So then when we're finding the interquartile range, we simply take our quartile 3, which in this case is 2.6. And we subtract our quartile 1, which is 1.1. You might have slightly different values, which gives us an interquartile range of 1.5. You will also need to use the curve to estimate proportions. Exactly the same method as the median and quartile by finding the point and going across, but it will be at the appropriate point. And you need to check the wording as to whether a subtraction is needed. Is it more than a particular value or less than a particular value? We'll see some examples that will include these 2 points. Let's have a look at this in example number 2. Karina asked 200 students how much pocket money they get each week. The following cumulative frequency diagram gives the information about her results. We're asked to use the graph to find an estimate for the median amount of pocket money. So to be able to find the median, we need to find the total. From our graph here, we can read 200 divided by 2, 100. Take your ruler to 100, draw a line across to the cumulative frequency diagram, and then draw a line down. And we can see here our value for the median is 6.6. In the context of this question, £6.60. This here is for the median. We're then asked to work the lower and upper quartile out. So to find our quarters, 200 divided by 4 is 50. So at this point here, we have our lower quartile, and at this point here, we have our upper quartile. Take your rulers out again, and we're drawing lines across to the cumulative frequency curve and down. And again here at 150 for the upper quartile, and down here. So reading off our values for our lower quartile, we have 6, and for our upper quartile, we have 7. So that's £6 and £7. From those easily, we can work out the interquartile range by subtracting the upper quartile, subtracting the lower quartile. So we have an interquartile range of 1. Let's now have a look how we can estimate the mean and quartiles from a list of data. So instead of a cumulative frequency graph, we're now looking at a list of data. Now, two really key points here. You must put the data in order and then divide it into 2 halves. What's going to happen then varies whether we have an odd number of values or an even number of values. So let's take a data set here. For example, when the numbers 4, 6, 10, 10, 12, 14, and 18. So here we have 7 numbers. We have an odd number of values. There will be a single value in the middle, and this is equal to the median. So having a look here, the number in the middle is 10. 3 this side, 3 this side. So in this case, this is our median, 10. It's halfway along the data set. Now you have to delete this. So we cross off the median and we repeat with the first set of numbers to find the first quarter, the lower quartile, and the second set of numbers to find the upper quartile. So we're looking at these numbers and we're looking for the middle number, 4, 6, 10. Obviously the middle number is the one in the middle here, 6. This is the lower quartile. Over this side, the number in the middle, remember we've crossed this out in the middle, this one here is the upper quartile, Q3. Now let's see how this varies if we have an even number of values. So let's just take down the same numbers again and we will add an extra number. Oh, just missed out 14, 14, 18, and then let's add 21 on the end. Okay, so we're going to find the middle number. Notice here from the notes that there is going to be 2 values in the middle. If we look here, going across, we can see that the 2 numbers in the middle are here. We have 3 this side and 3 this side. So we're going to have to find the mean. So we add up our 2 numbers in the middle and divide by 2. 22 divided by 2 gives us 11. So 11 is the median. When there's an odd number, add up the 2 numbers in the middle and then divide by 2. Now we do not delete either value, but we divide the data set into 2. So we're going to divide the data set into 2. 4 numbers this side, 4 numbers this side. And we repeat again what we did. We've got 4 numbers. Which numbers are in numbers are in the middle? We can see we have 2 numbers in the middle again here. And on this side, we also have 2 numbers in the middle. So we're going to repeat again, add them up, divide by 2. 16 divided by 2 equals 8. Here, 32 divided by, so adding these 2 up, 32 divided by 2 is equal to 16. So this is the upper quartile, and here our 8 is the lower quartile. Let's take a look at example 3. During one milking session, a farmer records the amount of milk in litres collected from each of his cows. The results are shown below. We can see that the results are in order, starting from 12 up to 43. We're asked to find the median amount. We have an odd number, therefore there is only one number in the middle, which is 31. 1, 2, 3, 4, 5 this side, 1, 2, 3, 4, 5, 5 this side. So the median is 31. Now, we ignore this number here and we look and find the middle on the left here to find the lower quartile. Our number here is in the middle, 2 this side, 2 this side. We're looking here, 34 is in the middle, 2 this side, 2 this side. This is Q3 and this is Q1. To be able to work out the interquartile range, Q3 subtract Q1. 34 subtract 26 is equal to 8. Interquartile range is 8 litres. Drawing box plots. There are several vertical lines that are really important on a box plot, and they're listed here, 5 different lines. We have the lowest value, and this is a smaller line. We then have Q1. We then have the medium. We then have Q3, and then we have the biggest value. Now these will be joined by horizontal lines, that's Q1 and Q3. Here Q1, Q3, the medium line. And here our smaller lines will then be joined to the box. So they're the main features of a box plot. There may well be an X this side or an X this side. These are outliers, and we will look at how to calculate those in a moment. If you're drawing more than one box plot, or if one is already drawn, make sure that the vertical lines, these lines here, are the same size on both box plots. So follow what has been done already for you. Really important around the lowest and biggest value. If it's not known, it will be the value of the first class, the lower value of the first class interval. And here for the upper end, it will be the end of the upper end of the final class interval. And we'll see some examples where we have to identify the lowest and biggest value. So here we have a box plot that shows information about the distribution of weights in grams of a random sample of 36 Bramley apples. We're then given some information about a sample of 36 Granny Smith apples. Here we have the different values we need, and we're asked to put this onto the box plot. So we're going to do exactly the same size, use the same colour as well for here. So our smallest value is at 204. Smallest value at 204, that will be 202, 204 will be here. So a horizontal line, it doesn't go the full way, it's a smaller line. The lower quartile at 214, this will take up 2 boxes, the length of 2 boxes, as it has done here. The median, 228, will be a line here. Upper quartile, 240. And the highest value, 252. Smaller there. We then join Q1 to Q3. Here and here to create the box. And joining here and here. Now, calculating outliers. You must mention the calculation. Outliers can be calculated by taking the Q1 and subtract 1.5 multiplied by the interquartile range. Similarly, an outlier that's going to be high, a big outlier, will be found by taking Q3 and adding 1.5 times the interquartile range. It's really important that you show this calculation in your working. From this, you can then make a direct comparison with the relevant data items. Let's take a look at this list of data here. This was the data from our previous example around the milking of cows. Now, we worked out on this that the interquartile range was 8, and we got that from taking Q3 and Q1. Now, looking back at the values for this, we had Q3, the upper quartile, being 34, and the lower quartile being 26. And we're asked, is 43 an outlier? The number up here, is it an outlier? So we're going to apply our calculation here. This part is for the lower end. So this is the one we're going to use. So taking what we need to do here, Q3, add 1.5 times the interquartile range. So the Q3 is 34. And we add 1.5 times 8. 1.5 times 8 is 12. 34 add 12 is 46. 46 is the largest a value can be and not be an outlier. So 46 is greater than 43. So 43 is not an outlier. If we had a number such as 53, this would be an outlier because it's beyond the limit that we have here from the calculation. Now, lastly, we may be asked to make comparisons from the distributions. You can be asked for specific information, e.g., what is the median? And this is easy to answer. However, you can be asked to just generally compare the distributions. Now, there are three things you must mention. First off, the median. You must compare and say which is bigger. Quote actual values. Similarly, you need to talk about the interquartile range or the range. This is about the spread of the data. Again, compare, say which has got a bigger spread, a bigger interquartile range or range, and quote values again. A third thing you might want to mention is relation to skew. If most values are near the start, then this is a positive skew. If most values are near the end, this is a negative skew. And we can see this from box plots diagrams easily, where we have a box plot and Q1 will be nearer to the medium. So a medium this end will be a positive skew. Whereas if we have a box plot and the medium is this end, closer to Q3, then this is a negative skew. So this might be something you can identify from the box plot when comparing. Example number 6. There's been research into the survival of red squirrels. A large number of adult red squirrels and a large number of adult grey squirrels were weighed. The summary statistics of the body weights are shown in the table. A box plot is being drawn on the grid to show the distribution of weights for the red squirrel. We're asked to plot for the grey squirrel. So, taking your ruler, we're going to use the same lengths that are used here in our box plot that's already been plotted for the red squirrel. So our first point is going to be our minimum, 300. So here we're going across to 300 and we're going to be drawing a line here. Okay, our next point is the lower quartile, 450. So we will be coming across here, 400, and across to 450. This line will be slightly longer, the one for the actual box. Our medium weight, our next line will be at 500. And our upper quartile at 570. We have 500, 550, 60, 70. So a longer line here. Now we have our box. We can connect our lower quartile with the upper quartile, as well as here, our minimum value to the box. And then on the other side, our last line we must draw is for the maximum weight at 620. So that was a smaller line just here, again connecting through. We're then asked to describe the skewness of each of the distributions. So taking a look here now, we have the red squirrel and we're looking at the box. We're looking here at Q1, Q2 and Q3. We can see that these are perfectly distributed identically. Here we have 40, here we have 40, the difference. This is a symmetrical distribution. However, when we look at the grey squirrels, the median is closer to the lower quartile. That means more of the points are distributed towards this end. This is a positive skew. So for our red, we have a symmetrical distribution. And for our grey, we have a positive skew. We're then asked to compare the distribution of the weights of red squirrels and the weights of grey squirrels. So we're asked to make some comparisons. There are lots of things that we can say in relation to the red and the grey squirrels. You need to make at least 2 points. First off, make a comment in relation to the mean. Having a look at our mean, we have our red mean at 300 and our grey mean at 500. So the grey has a higher mean. Grey, higher, medium. So first thing to comment on is the medium. We then need to look at the spread. Now we can look at the spread by looking at the range, which will be from our lowest value to our biggest value. And we can see here and we can see here. Now we can actually work out the values by subtracting. Here we have 620, subtract 300, and 360, subtract 240. And we can see that the grey has a much, much bigger range. Here, our range is equal to 120, and here, our range is equal to 320. Much bigger range. We can also talk about the spread of the data by looking at the interquartile range. The interquartile range is found by taking the upper and subtracting the lower. If we do that here, for the red, the interquartile range is equal to 80. And here for grey, the interquartile range is equal to 120. So once again, the grey has a bigger spread. It doesn't matter if you use the reason by backing up using the range calculation or the interquartile range. So we have a greater spread. And again, you need to reference why the range is bigger or the interquartile range is larger. We're then told that some grey squirrels have a lot of red fur and some red squirrels have some grey fur. This means that it's not always possible to tell if a squirrel is red or grey by looking at the colour of its fur. There are red squirrels and grey squirrels in a wood. How would you use the box plots to help you find whether a certain squirrel is a red or grey? So if we find a squirrel, we're looking at the fur. So we're not sure because red squirrels have grey fur and grey squirrels have red fur. First off, we need to weigh them. This information that we have is all to do with the weights. If we knew the weight, then we would be able to work out with a certainty not with certainty, but with a degree of certainty, whether it is a red or a grey squirrel. So first step is weighing them. Now, if they weigh more than 360, we're looking here that the largest, the heaviest squirrel in the sample is here at this point at 360. So it would suggest if we weighed the squirrel and it was more than 360 grams, it's likely to be a grey squirrel. And if it is less than, change the colour here, less than 300, we can see here, less than 300, we don't have any squirrels in the sample that are less than 300, therefore they're likely to be a red squirrel. So there are the 2 points there that you really need to identify from your box plots. So if we see more than 360, it is likely to be grey. If we weigh them and they are less than 300, using the minimum value for the grey, they are likely to be red squirrels. It's now time for you to do some questions. Press pause on the video and complete as many questions as possible from the question booklet. Once you have completed these, come back to the video, press play, and we will go through the questions together. Question 1. The box plot shows information about the distribution of weights in grams of a random sample of 36 Branbury apples. Write down the median weight of the sample of Branbury apples. This line here is the median line. Coming down here, reading off the scale, 130, 132, 134, 136, 238 grams. We're then asked to work out the interquartile range of the sample of Branbury apples. To find the interquartile range, we take quarter 3 and we subtract quarter 1. This is quarter 3 here at 245, and this line is quarter 1 at 226. Subtracting those two values, 19 grams. We're then provided with a random sample of 36 Granny Smith apples and given the summary statistics here in the table. We're asked to draw this on the grid. So looking back here at our grid, our first point here for the smallest value will go at 204. So here, 204. The lower quartile, quarter 1, 214 here. The medium, 228 here. The upper quartile, 240, and the highest value, 252, just here. Connecting these, the Q1 with the Q3, and extending here out to the largest and smallest value. Excellent. Okay, next question. We're asked to compare the distributions. We need to compare the Granny Smith with the Branbury. So first off, we're looking at the median. The first thing to compare the distribution is the median. Which one has the highest median? We can see here that Branbury apples higher median. Then looking at the spread, which one has the biggest interquartile range? Well, we worked out the interquartile range for Branbury apples, and that was 19. So let's work out the interquartile range for the Granny Smith. Q3 is 240, and Q1 here, 214. An interquartile range of 26. This is larger than this. So Granny Smith, higher interquartile range. We're then told that a supermarket wants to have a small variation in the weight. Which of these two distributions has the smallest variation in weight? And give a reason for your answer. The smallest variation. Well, variation is to do with what we have just worked out here for the interquartile range. We can see that Granny Smith has the higher variation. So if a supermarket wants to have the smallest variation in weight, it needs to select the Branbury apples. So Branbury apples, why? Smaller interquartile range. You can also see here in terms of the range, our range here goes from 254, subtract here 218. We subtract these two numbers and we get 36. The range here is 36. When we look here at our range, we're going from 204 all the way up to here at 252. So our range is significantly bigger at 48. So again, the Branbury apples have a smaller interquartile range and a smaller range. Our answer there for part E. Question number 2. 11 10-gram portions of dried egg were taken from a large, well-mixed tin and sent to a laboratory to be tested for their percentage fat content. Here we have the percentages. We're asked to find the lower and the upper quartile. Our first step is to identify the medium. We have an odd number of numbers. This here, 0.4, is the medium, the middle value. We can see that there are 5 values to the left and 5 values to the right. This is the medium. To be able to find the lower quartile, we look at the values to the left. The middle value, here, 0.37. This is the lower quartile. Looking here to the right, our middle value is 0.45. This is our upper quartile, Q3. So our answers here are lower quartile, 0.37, and our upper quartile, 0.45. We're then asked to draw a box plot for these data given that the median percentage fat content was 0.4. We've worked that out already when we were working out the quartiles. So, using a box plot, we can see later in the question that there's one being drawn for us. So we're going to use approximately the same size lengths that have been used in the next box plot below. So our minimum value, the smallest value here we have, is 0.27. So looking here, we've got 0.2, 0.25, 0.27 is 2 along. So drawing our minimum line for the first line of the box plot. We then have our lower quartile, which is at 0.37, which is our larger line here. Moving on now to our medium at 0.4 here. And our upper quartile at 0.45. Connecting our lines to create the box. And then our final value here for our maximum value, 0.54. So slightly smaller line. And then connecting to the box here, the whisker part, and here. Just to make sure they're straight and as neat as possible. Same thing on this one. Just make sure you haven't extended it. Yeah, just into the box there. So we're then told that a second sample of 11 10-gram portions from the same tin was sent to a different laboratory. The box plot gives information about the percentage fat content of this second sample. We're asked to compare. Once again, we're going to compare using the first step of looking at the medians. We can see here our median, 0.37, is lower than our median for the first sample. So we can say here, second sample, lower median. Or say, put another way, the other way around, first sample, higher median. Moving on to the next comment that you want to make is in relation to the spread, the range or the interquartile range. We can find the range by looking here at our values, our minimum and our maximum, and here and here. We can see that our range is larger for the second set of data, the second sample. We can also have a look at the interquartile range. We can see here that our interquartile range from 0.37 to 0.45 is smaller than our range for our second sample. So on both accounts, both the range and the interquartile range, the second sample has greater spread. Again, put the other way around, our first sample has a smaller spread. Question number 3. The table gives information about the typing speed in minutes in words per minute of a random sample of 60 typists in a typing agency. We need to complete a cumulative frequency table. So looking from our information up here, first value is 10. Add 22, 32. Add 14, 46. Add 10, 56. Add 4, 60. These are our cumulative frequencies. Transfer them into the box if you have also done them where I have. Check your 60 corresponds with a 60 in the question. Okay, so we're now going to plot this information onto the cumulative frequency diagram. Here we need to add some axes in. We start here with 0, and our cumulative frequency goes up to 60. So it would be sensible to go up here in tens. Three, 4, 5, here 50, and then again here 1, 2, 3, 4, 5, 60. And this is the cumulative frequency. Across here, we're going from 30 up to 80. So if we start here at 30, I'm going here 40, 50, 60, 70, 80. And this is the number of minutes. So plotting our points, remember where we're plotting the points from. We're going the upper or the cumulative frequency. So first point 40 and 10, right there. 50 and 32. 60 and 46. 1, 2, 3. 70 and 56. 80 and 60. So we're then going to join these up to make a smooth curve starting from the origin. Smooth curve through, making sure you're using a pencil here so you can rub out any mistakes, and then the plateau, the flat lining to the final coordinate. We're then asked to use the cumulative frequency diagram. We've got to do something above to estimate the median. Okay, so we have 60 typists. We're going to divide by 2 to find the middle one. It's 30. So take our rulers out. From 30, going across to the line, and then down here to the x-axis. And we have a value of 49 in this case. Again, the mark scheme in the exam allows an answer any from 49 to 50. Question number 4. Here are the ages in years of 7 people. For this data, write down the mode. The mode is the most common. Here we have 2 for 69. We're then asked to find the median. We must put these numbers in order before we can find the median. So putting them in order, we have 69, 69, 70, 71, 80, 83, and 90. Crossing out to find the middle number, we can find here like this. Find there's one number in the middle because we have an odd number, 71. This is the median. We're then asked to work out the mean. To work out the mean, we are going to add up all of these numbers, the 7 numbers, and divide by 7. Adding up all of those, we get 532. Dividing through by 7, we get 76 years. We're then told that a person aged 73 joins the group. So we have a new person who comes in here, 73. So we write out our numbers again, 69, 69, 70, 71. The new person, 73, 80, 83, 90. We now have an even number of numbers. We have 8 numbers. So there are 2 numbers in the middle here, 3 this side, 3 this side. To find the median, we must add them up and divide by 2. Adding them up, dividing by 2, 72 years. This will be the new median. Question 5. Some female students were asked to read an essay. The time taken to the nearest minute for each student to read the essay was recorded. The information is summarized in the cumulative frequency diagram. So here we have the cumulative frequency diagram drawn for us. we're asked to write down the number of students in the group. The total of the cumulative frequency, the final point there, 40. Total number in the group, 40. We're asked to find the median. 40 divided by 2 is 20. We need to draw our line at 20. So take your ruler, and we're drawing a line across to the cumulative frequency diagram, and then down, really precisely down here. Okay, so here, if we look at this number really precisely, it comes out as 34.5. In the mark scheme, any number between 34 and 35 is accepted. We're then asked to work out the number of students who took less than 38 minutes. So we need to find 38 along our x-axis. It's here. Take your ruler again and drawing a line from 38 up to the cumulative frequency, curve and across. Across there, we can see that the cumulative frequency is 30. So the number of students who took less than 38 minutes, remember less than is going to be all of these. These people took more than the 38 minutes on this side. So our answer there, 30. Question 6. A holiday company recorded the ages in years of people on each of 2 tours. The ages of people on tour A are summarised in this box plot. We're asked to describe the skewness of the distribution of the ages of people on the tour. We're looking at this line. This is our median. It's closer to Q3 than Q1. Therefore, we have negative skew. We're asked what percentage of these ages lie between the upper and lower quartiles. So between here and here, we have 25%. From here to here, we have another 25%. These quarters split the distribution. Here's 25, next 25, next 25, next 25%. So between the upper and the lower quartile, we have 50% of the distribution. We have a further 25% this side and a further 25% this side. We're then given the ages of the people on tour B. You can see here that our ages are in order from 32 up to 86. And we're asked to find the middle number. The middle number is here, 51. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers below and 11 numbers above. 51 is our middle number. To find the lower quartile, we're looking at these numbers here and we're finding the middle value, which is 44, just here. We can count 1, 2, 3, 4, 5 above, 1, 2, 3, 4, 5 below. Similarly, this number here, 5 above, 5 below, will be the upper quartile. We're then asked to show that 86 is an outlier for the people on the tour of B. To be able to find an outlier, we must take quarter 3, add 1.5 the interquartile range. We know the upper quartile is 58. Add 1.5 times the interquartile range. The interquartile range is a difference between these two. So 58 subtract 44 gives us a value of 14. We then have 58 add 21, which is 1.5 multiplied by 14, which gives us 79. 79 is the limit, and we can see here that our value of 86 is greater than 79, so it is an outlier. We're told that there are no other outliers. 86 is the only outlier. And we're then asked to plot the information here in a box plot so that we can compare the distributions of ages with tour A. So taking our rulers out, we need to identify the key points on our box plot. So the lowest age is 32. So we have a value here for 32. Our lower quartile Q1 that we have worked out is 44. 44 is here. Our median, 51, here. Our upper quartile, 58, here. And the largest value, excluding the outlier, is 70. We put a point here. Now, joining these up to form the box between quarter 1 and quarter 3. And then same here and here. We must then mark the outlier, 86, which is along here, 85, one more, 86. This is the outlier. And the furthest point here is the next biggest number, which is 70. We're then asked to compare the distributions. First off, we need to talk about the median. Tour A, higher, medium. The average age is higher on tour A than it is on tour B. Then looking at this spread, we can see here that the box is smaller than here. Same here, the range. So tour A has a higher spread. Now that word can be replaced by interquartile range or range. So they're the two key things that you need to put down. Other things that will be accepted are things in relation to the skew. We can see here that A has a negative skew. Q2 is nearer to Q3. So A has a negative skew. And we can see here in tour B that the median is in the middle. So B is a symmetrical skew. And that would be another comparison between these two tours. Question number 7. In a study on identical twins, the intelligence quotient, IQ, of 10 sets of twins was tested, and whether the twin was the first or the second born was recorded. The results for the second born twins are shown in the stem and leaf diagram below. Here we have a key, and we're asked to find the median IQ of second born twins. The median is the middle value. So we can cross off our smallest value and our largest value. Our next smallest, our next largest. Our next smallest, our next largest. 3 below, 3 above. Our next smallest, our next largest. We then have two values here in the middle. This value is 96 and this value is 97. To find the median, we're going to add them up and divide by 2 to give us our median of 96.5. We're then asked to find the lower and the upper quartiles of the IQs of the second born twins. Having a look here, we're going to split our data because we have an even number. We split here through the middle. We are then looking for the middle point. Here, our lower quartile, 2 numbers below, 2 numbers above, will be 93. Our upper quartile, 2 numbers below, 97, 101. Number in the middle, 103. And 2 numbers above. This is our lower quartile and this is our upper quartile. We're then asked to show that 126 is not an outlier for the second-born twins' IQ. Using our definition of outliers, 126 is a larger value. So we use the definition whereby Q3 plus 1.5, the interquartile range. Well, let's work out the interquartile range. We can do that here by looking at the differences between the upper quartile and the lower quartile. And we have this as 10. The interquartile range is equal to 10. Now, substituting that value in here, we know Q3 is 103, and we add 1.5 times our interquartile range of 10. So we have 103, add 15, gives us the value of 118. Now we can see here that 126 okay. This is a mistake. It should have been removed before. I will remove it and restart the question. I'll make a note and put it in the email as well. So question 7, and this is video number 6, needs to be restarted. Just clear all the annotations and start again. Okay. I'll block this out now on the screen so that it won't show up, and it will be the same in the kids' papers. That needs to be darker. Okay, so let's start again. Okay, starting again now. Question number 5. In a study on identical twins, the intelligence quota IQ of 10 sets of twins was tested, and whether the twin was the first or the second-born was recorded. The results of the second-born twins are shown in the stem and leaf diagram below. We're asked to find the median, the middle value. Taking a look here at the middle value, we see that there are 2 numbers in the middle, 4 below, 4 above. We add up our 2 values, this value here, 96, add 97. Divide by 2 gives us our median value of 96.5. We're now going to take a look at the lower quartile. Doing this, we split our distribution in 2. We look here to the left of the line. Our middle value is our 3, our 93. This is the lower quartile. Looking now for our upper quartile, we are looking here. We've got 97, 102, and our middle value here, 103. 2 numbers below, 2 numbers above. The upper quartile is 103. We're then asked to show that 126 is an outlier for the second-born twins' IQ. 126 is towards the end, it's the upper part of the distribution. So the definition for an outlier that we will apply to show is quartile 3 add 1.5 interquartile range. So first off, we know that the upper quartile, Q3, is 103, and we add 1.5 times the interquartile range. We're finding the interquartile range here by looking at the difference between the lower and the upper quartile. Subtracting them, we get a value of 10. This is the interquartile range. Substituting that in here, we have our 10. So we have 103 add 15. 103 add 15 gives us a value of 118. Anything beyond this point greater than 118 is an outlier. So we need to state here that 126 is obviously greater than 118, therefore it is an outlier. This question then moves on and says that the IQ for the firstborn twins are shown as a box plot in the grid below. On the same grid, we're asked to draw a box plot for the IQ for the second-born twins. We're going to use our information from the previous page. First up, we're going to draw the minimum value. So here for our second-born, we are looking at the minimum value as 87. Looking at our scale here, we're going in twos, so 82, 4, 6. Halfway will give our value for 87. So a straight line here. We're then looking for our lower quartile, which is 93. So a longer line here for 93. Our median, 96.5. So we're looking here at 96 and we're going across a little bit further for 0.5. Not 97, just 96.5. And then our upper quartile, 103. 102, halfway, denotes here on the scale 103. Lastly, our maximum value that is not the outlier. So we're looking for 113. This is the largest value that is not the outlier. Connecting up now to show the box. Here have our whiskers. And lastly, we need to put in the outlier. The outlier is 126. So going across here, we show our outlier with a cross. We're then asked to compare the two distributions. As always, we want to talk about the median and we want to talk about the spread. So let's take a look at the median. We can see here that our median is higher than our second-born. So first comment that we want to make is that the first-born, higher median. Following on from that, we need to look at the spread. We've looked at the spread by both the range and the interquartile range. You can see here from here to here, compared to here, that the firstborn has a much larger range. Same thing when looking at the interquartile range. The box here is significantly bigger than the box here for the second-born. So our next comment is that the firstborn has a greater spread. And that can be based on either quoting the range or the interquartile range. Remember, we can say these the other way around: second-born, lower mean; second-born, less spread. Another comment that you might want to make in relation to this is that both of the distributions are positive skew. We see here that the median is closer to the lower quartile than the upper. Similarly here, the median is closer to the lower quartile. So both first and second-born have a positive skew. Again, only 2 marks are available, so any of these 2 points need to be made. Lastly, we're asked to suggest one way in which the study could be improved. Obviously, we are only looking at a very small sample. We only have 10 sets of twins. So actually, to improve this always is to increase the sample size by collecting more data. Collecting more data will increase the reliability of this study. Question number 8. The weights, the nearest kilogram of 19 pigs are shown here. We're asked to find the interquartile range of the weights. To be able to do that, we need to look first for the median. We're unable to do this until these weights are in order. First step, we must get these weights into order. So looking for the smallest number here, we have 25, 30, 30, 31, 33, 34, 36, 36, 37, 37, 38, 38, 38, that looks like the mode, 40, 41, 43, 48, and lastly 55. Before you move on from this point, check that you have 19 numbers. We have an odd number, therefore we have one number in the middle for the medium, which is here, 37. This here is the medium. To be able to then find the upper and lower quartile, we will ignore this number. We will then find the middle of our lower numbers. The middle of our lower numbers is here, 33. This is the lower quartile. 4 numbers below, 4 numbers above. Our upper quartile is here. Oh, I've missed a number, so I'm going to have to just go back to the beginning of this question. So question number 8 needs to be restarted from the beginning. Okay, restarting question number 8 again. Question number 8. The weights, the nearest kilogram of 19 pigs are shown here below. We're asked to calculate the interquartile range of the weights. To do that, we need to make sure that these weights are in order. So our first step is to rewrite this list, starting here with our smallest number up to our largest number. So the smallest number here is 25. We then have 30, 30, 31, 33, 34, 36, 36, 37, 37, 38, 3 times, 40, 41, 43, 43, 48, and 55. Before moving on, check that you have 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Excellent. We have an odd number, therefore we only have one number in the middle. The number in the middle is here, 37. This is the medium. To be able to find the upper and lower quartiles, we will cross this number, ignore it, and find the middle here. Looking at our numbers here, finding the middle number is here at 33. 4 numbers below, 4 numbers above. This is the lower quartile, quartile 1. Looking here now to the other side, we can see our upper quartile is 41. Similarly, 4 numbers below, 4 numbers above. Interquartile range is therefore found out by 41 subtract 33, which is equal to 8. We're then asked to find out any weights that are outliers. To be able to do this, we need to look at the lower and the upper end. First off, looking at the lower end, we will apply the formula shown in our notes earlier in the video. We will take Q1 and subtract 1.5 times the interquartile range. We will then look at the upper by taking the upper quartile and adding 1.5 times the interquartile range. Substituting in our values for that, we will have 33 take away 1.5 times 8, which gives us 21. This means that any number below 21 is an outlier. We therefore have no outliers because our lower number here is 25. But let's check at the other end of the distribution. Substituting our values here, we have 41, add 1.5 times 8, which is equal to 53. This means any number larger than 53 is an outlier. Do we have any numbers larger than 53? Yes, this number is an outlier. So make that clear here. 55 is greater than 53, therefore it is an outlier. So we must mark that when we're asked to plot the information onto the box plot here. So we can mark that on as the first point. So 55 here, we are looking at the outlier. So this point here at 55 is our outlier. Okay, looking now at our smallest value, our minimum value, and our largest value. So our largest value, except for the outlier, is 48. So going across here to 48. So we will go here. And our smallest value at the other end is 25. So just a small mark for the minimum and maximum values. Then we will do a larger mark for the quartile 1, which in this case, we can see here is 33. So we're having a larger mark here. Again, we need to make sure that it's symmetrical. And the same for our medium at 37. So 33, 35, 37 is here. And then our final value for our upper quartile at 41. Here, connecting our box. And then connecting our whiskers here from our minimum and here out towards our maximum. We're then asked to name the distribution. We need to look here and we're looking for the skew. Here we have a symmetrical distribution. The box plot has the same space here as it has here. This is a normal distribution. Why? Give your reasons. Why? Because we have a symmetrical distribution. The box plot shows symmetry. We're then told that the weight of a full-grown pig is about 45 kilograms and asked, what does this suggest about the 19 pigs? So the weight of a full-grown pig is around 45 kilograms. We can see that most of our distribution is less than that. Over 75% of our distribution is less. Therefore, these pigs are not fully grown. Maybe they are young baby pigs. We need to say here that it suggests that the pigs are not fully grown. So we've now come to the end of session 6. Please revise the list of subtopics here on the screen and replay the video for any sections that you would like to study again.